In 1989, a group of engineers in Europe looked at the specification sheet of a new Japanese car and simply refused to believe it. Not because the numbers were wrong, but because those numbers described a machine that broke an assumption every one of them had built their careers on. The assumption that speed and comfort were enemies, that a supercar was allowed to be difficult because difficulty was supposedly the price of greatness. That single car would quietly force almost every major manufacturer on the planet to rewrite a rulebook they thought was permanent. This is not a story about fast cars. This is a story about engineers handed a brief nobody thought was achievable, who built it anyway, so far ahead of what the industry believed possible that entire companies spent the next 20 years catching up. Stick with me until the end, because the 8th car on this list did something so mechanically absurd that the engineers who approved it were not entirely sure it would survive its own assembly line. Number 1. The 1990 Honda NSX. To understand why this car terrified an entire industry, you have to understand what a supercar meant in 1989, the year Honda unveiled it at the Chicago Motor Show. European supercars of that era were built on an unspoken contract with their owners. They were breathtakingly fast, visually dramatic, and almost proudly unreliable machines that demanded expert handling and a tolerance for mechanical tantrums that would embarrass a normal car. Difficulty was not a flaw. Difficulty was the point, or at least that was the story the industry told itself. Honda spent 6 years quietly dismantling that story. Engineers ran prototype sessions at the Suzuka circuit with Ayrton Senna himself behind the wheel. And Senna did not just test the car, he reshaped it, providing direct feedback that altered the final suspension geometry, until the chassis behaved the way he believed a road car actually should. The result was the first production car in the world, with a fully aluminum monocoque chassis and body structure. A decision that saved roughly 200 kilograms compared to steel. Weight Honda did not use to simply build a lighter car, but to extract a power-to-weight ratio from a naturally aspirated 3.0-liter V6, producing 270 horsepower, a number that looked almost modest on paper next to Italian rivals pushing far bigger numbers from far bigger engines. But the NSX was not competing on paper. It was competing on how it actually felt to drive it at the limit. And that is where Honda's obsession became impossible to ignore. The aluminum suspension shaved another 20 kilograms and delivered a handling precision that road testers at the time struggled to find the right words for, because nothing else on sale behaved quite like it. Honda layered in VTEC, a variable valve timing system that let the engine behave smoothly at low revs and savagely at high revs from the exact same block. Technology the rest of the industry would spend the following decade trying to replicate in one form or another. And then Honda did something almost insulting to the rest of the supercar world. They gave it a 3-year warranty. They gave it air conditioning that actually worked. They built a car reliable enough that an owner could drive it to the office on a Monday morning and onto a racetrack the following Saturday without a single compromise between the two. Gordon Murray, the man who would go on to design the McLaren phone, one of the greatest road cars ever built, publicly credited the NSX as a direct inspiration for his own engineering philosophy. Think about that for a second. The most respected automotive engineer of his generation looked at a Japanese company's first attempt at a supercar and said, "This is how it should be done." The NSX stayed in production until 2005 without a fundamental redesign. Not because Honda ran out of ideas, but because what they built in 1990 was already correct. Ferrari's internal response, according to people who were inside the company at the time, was to immediately begin improving their own cars. A Japanese manufacturer had just moved the entire benchmark, and it would not be the last time that decade. Number 2, the 1989 Nissan Skyline GT R32. And this is where things get genuinely unfair. Nissan launched the R32 under an internal initiative called Project 901, a program with one explicit, almost arrogant objective to make Nissan the world leader in dynamic vehicle performance by 1990. The GT-R was the sharpest, most complete expression of that mission, and it arrived carrying 2 systems that had essentially no equivalent anywhere in the production car world at any price point. The first was Atessa ETS, an electronically controlled all-wheel drive system that operated in pure rear-wheel drive mode, under normal conditions, and transferred torque to the front axle only the instant the rear wheels began losing traction, reading inputs from all 4 corners continuously and adjusting in real time. It gave the car the raw, direct feel of a rear-wheel drive machine during normal driving, while quietly providing all-wheel drive grip the second things got dangerous. The second system was super hikis, four-wheel steering that turned the rear wheels in the same direction as the front at higher speeds, stabilizing the car through lane changes and long sweeping curves in a way that made the GT-R feel like it was cheating physics. Combined, these two systems gave the R32 a level of dynamic capability that dramatically outperformed its official power figure, 276 horsepower, a number that existed only because of a voluntary agreement among Japanese manufacturers to cap official output regardless of what the engine was actually producing. Everyone in the industry knew the real number was higher. Nobody could prove by how much until the car started racing. The GT-R entered the Japanese Touring Car Championship and did something almost cruel to the sport. It won every single race it entered from 1990 through 1993. 29 consecutive victories, forcing officials to introduce success ballast, and eventually entirely new regulations just to give other manufacturers a fighting chance. Australian touring car racing did not bother trying to regulate it. They banned it outright. And the Australian press gave it a name that stuck to the entire GT-R bloodline forever: Godzilla. Tuners who got their hands on the RB26 DET twin-turbocharged inline-6 discovered something the factory numbers had been hiding all along. An engine block so overbuilt, so absurdly over-engineered relative to its stated output that it could absorb power increases that should have destroyed a normal production engine and simply ask for more. The 32 did not just win races. It proved that a mainstream Japanese manufacturer, working within a self-imposed power cap, could still build a machine that made European engineering departments nervous. And we are only 2 cars in, because the next one on this list did not just push an engine to its limit. It committed to an engine design almost every other manufacturer on Earth had already thrown in the trash. Number 3, the 1991 Mazda RX-7 FD. And if you want to understand real engineering stubbornness, this is the car to study. Mazda had been building cars around the Wankel rotary engine since 1967, at a time when literally every other manufacturer that had investigated the same technology walked away from it, concluding it was too mechanically complex, too fuel-hungry, and too commercially risky to bother with. Mazda disagreed, and kept disagreeing for over 2 decades. The third-generation RX-7, introduced for the 1992 model year in export markets, was the fullest, most refined expression of that stubbornness. And it remains one of the most mechanically coherent performance cars built anywhere in the world that decade. The FD's 13B RU-W twin-rotor engine used 2 sequential turbochargers, a small one that spooled almost instantly at low RPM to eliminate turbo lag, and a larger one that took over at higher engine speeds to sustain power through the top of the rev range. The result was 255 horsepower from a displacement of just 1.3 liters. No conventional piston engine on the planet in 1991 produced that kind of output from that little displacement in a road car. None. The rotary's complete absence of reciprocating pistons and a traditional valve train gave it a power delivery unlike anything else in production. Smooth, continuous, almost eerily linear compared to the pulsing character of a normal engine. Mazda wrapped that engine in a chassis weighing just 1,260 kilograms, achieved a near-perfect 50-50 front-to-rear weight distribution through obsessive component placement, and had the entire shape styled by Yoichi Sato into a body that still, 3 decades later, gets called one of the most visually resolved sports car designs ever put into production. But here's the turning point in the story, because this is where engineering brilliance ran directly into the limits of the world it was released into. That same sequential turbo system that made the engine so extraordinary also made it brutally unforgiving of neglect. Cooling demands were severe. Apex seals needed attention at intervals conventional piston engines simply did not require, and mechanics who had never worked on a rotary before, which was most mechanics outside of Mazda's own dealer network, frequently got it wrong. Owners who did not understand the car's specific maintenance language ended up with reliability problems the engine's design was never meant to tolerate in the first place. Mazda eventually pulled the RX-7 from most markets and discontinued it entirely in 2002 without a direct successor. No manufacturer since has built another twin sequential turbocharged rotary road car. Mazda committed to that engine concept for 35 years, and the FD remains to this day mechanically unique in automotive history. It was not killed by bad engineering. It was killed by being built for a level of technical understanding the market around it was not ready to provide. Number 4. The 1993 Toyota Supra RZ, and this is the one that eventually broke the internet decades after it was built. For reasons Toyota's own engineers almost certainly did not fully anticipate at the time. The fourth-generation Supra arrived with a straight-six-engine internally coated 2JZ GTE, twin sequential turbochargers, and a factory-rated output that Toyota, like every other Japanese manufacturer of the era, capped at 276 horsepower under that same voluntary industry agreement. On paper, that made it look like a fast but unremarkable rival to the RX-7 and the GTR sitting right next to it in the same showroom era. What Toyota's engineers actually built underneath that conservative number was something else entirely. The 2JZ GTE was engineered with a cast iron block dramatically overbuilt relative to its stated output, forged internal components, and tolerances so conservative that the engine had enormous untapped headroom baked directly into its design from day one. Nobody outside Toyota fully appreciated how much headroom until tuners, years later, began bolting on larger aftermarket turbochargers and discovering the stock bottom end could reliably handle power figures 2, 3, sometimes 4 times the factory rating without failing. That is not a normal outcome. That is not how production engines usually behave. Engines built to a specific power target are typically engineered close to their actual limits to save cost and weight, not left with a massive, expensive safety margin nobody asked for and nobody was billed for. Toyota's engineers, whether by deliberate philosophy or sheer conservative over-engineering culture, built a 6-cylinder block capable of handling stresses the car's own factory specifications never once suggested it needed to survive. The Supra RZ became, quietly at first and then explosively later, one of the most infinitely tunable production engines ever mass-produced, a reputation that eventually made it a centerpiece of global tuning culture and pushed used examples to prices that dwarf what they cost new, because the rest of the industry simply never built another engine with that kind of built-in ceiling. Here's the part that should genuinely unsettle you if you think about it long enough. Toyota's engineers built a machine so far beyond what the car itself was ever asked to do that its true potential would not be fully understood or exploited for another 2 decades. They were not building for 1993. They were, whether they knew it or not, building for a future audience of tuners and engineers who had not been born yet when the car left the factory floor. If you think that is the strangest story here, wait, because this next car stops being about raw power and starts being about priorities almost nobody else in the industry was willing to fund. Number 5. The 1992 Mitsubishi Lancer Evolution, born not out of a desire to build a great road car, but out of a desperate need to win a rally championship. World Rally Championship regulations at the time required manufacturers to produce a certain number of road-going versions of any car they wanted to homologate for competition. So Mitsubishi's engineers were not designing a comfortable daily driver first and a race car second. They were designing a genuine rally weapon, then legally obligated to sell a road version of it to ordinary customers. That inversion of priorities changed everything about how the car was built. The original Evolution paired a 2-liter turbocharged 4-cylinder engine producing around 250 horsepower with a full-time all-wheel drive system and a limited slip differential setup tuned not for comfortable commuting but for surviving unpaved forest stages at triple-digit speeds. Suspension geometry, steering response, even the weight distribution were all dictated first by what a rally car needed, and only second by what a road car buyer might want. The result was a machine that felt almost hostile in its intensity compared to anything else in a Mitsubishi showroom. A car engineers essentially smuggled onto public roads because motorsport regulations forced their hand, and it worked spectacularly. The Evolution's descendants would go on to win World Rally Championship titles across multiple decades, becoming one of the most successful rally platforms in the sport's history. While the road cars developed an entirely separate cult, following among enthusiasts who wanted a genuine competition mentality, they could legally drive to work. But the same intensity that made it a rally icon also made early Evolution models genuinely demanding to live with day to day. Stiff, loud, uncompromising in ways family sedan buyers were simply not shopping for. Mitsubishi's engineers were not building a car the average consumer was ready for. They were building a car regulators accidentally forced onto consumers, and the automotive world spent years afterward trying to figure out how to build homologation specials that combined that level of competition focus with something resembling daily livability, a balance the Evolution itself did not fully solve until several generations later. Number 6. The 1992 Subaru SVX, the least remembered car on this entire list, and one of the most unfairly forgotten pieces of engineering Japan produced during this era. Designed by the legendary Giorgetto Giugiaro at Redesigned and developed by Subaru as a genuine grand touring machine. The SVX arrived with a 230 horsepower flat-six engine, a sophisticated all-wheel drive system, and a drag coefficient of 0.29, a figure that matched or beat dedicated sports cars from manufacturers who built their entire brand identity around aerodynamic obsession. Its most visually distinctive feature was an aircraft-inspired window design, door glass split into two sections with only the upper portion able to open, creating a window within a window that dramatically cut wind noise at speed and directly contributed to the car's exceptional aerodynamic performance. This was not a gimmick. This was serious aerospace-inspired engineering applied to a road car nobody expected it from. But here is the turning point. And it is almost painful to talk about, because the SVX was undermined not by its engineering, but by a single stubborn decision that had nothing to do with performance at all. The only gearbox ever offered throughout its entire production life was a 4-speed automatic. No manual option was ever made available, despite everything else about the car practically begging for one. That one decision alone separated the SVX from exactly the kind of driving enthusiast who would have appreciated everything else it was doing right. Subaru discontinued it in 1996 after disappointing sales. And to this day, the SVX has never been fully reassessed by either the market or the enthusiast community at the level its actual engineering genuinely deserved. A car with Italian styling, a drag coefficient competitive with dedicated sports cars, and one of the most sophisticated all-wheel drive systems of its era, was quietly buried by a transmission decision that had nothing to do with how brilliantly engineered everything underneath it actually was. If you're starting to feel like these engineers kept getting punished for being too ambitious, wait until you hear what happened with car number 7. Because this one did not just challenge the market, it challenged manufacturing itself. Number 7, the 2010 Lexus LFA, a car so mechanically obsessive that Toyota's engineers essentially had to invent an entirely new production process just to build it. The LFA's body was constructed almost entirely from carbon fiber reinforced plastic, but instead of buying carbon fiber weaving machines from an outside supplier, Lexus engineers determined that no existing commercial equipment could weave the material the way their design required, so they built their own custom carbon fiber loom from scratch, specifically for this one car. Read that back. They did not adapt an existing production line. They engineered an entirely new manufacturing machine because the car they wanted to build did not fit into any process that already existed on Earth. The V10 engine at the heart of the LFA was co-developed with Yamaha's engine specialists and produced revs so quickly, redlining at 9,000 RPM, that Lexus had to fit an entirely digital tachometer, because a traditional analog needle physically could not sweep across the dial fast enough to keep up with how quickly the engine climbed through its rev range. Toyota did not build the LFA to make money. Production numbers were deliberately limited to around 500 cars, and by most public estimates, the company lost money on every single unit sold once you accounted for the sheer scale of custom tooling. From that hand-built carbon fiber loom to the bespoke engine development required to produce it at all. This was not a car built to satisfy a business case. This was a car built because a group of engineers were given the freedom, for once, to chase an idea with almost no commercial restraint, and the result was a machine so mechanically extreme that the production processes required to build it did not exist until Lexus's own engineers invented them. Almost no other manufacturer on the planet has been willing to burn that kind of money purely in pursuit of engineering ambition with essentially no expectation of financial return. And that is exactly why the LFA remains one of the most respected engineering achievements to ever come out of Japan, despite most people never having seen one in person. And now the 8th car, the one I promised you at the beginning, the one where the engineering ambition genuinely tested the limits of what an assembly line could physically accomplish. Number 8. The 1997 Toyota Century. And if you think a hand-built ultra-luxury sedan sounds boring compared to supercars and rally weapons, you are about to be proven completely wrong. The Century was built almost entirely by hand, powered by a 5-liter 12 engine, the only V12 Toyota has ever mass-produced. Developed specifically because Toyota's engineers believed a true flagship sedan needed a level of mechanical smoothness that no V8 or V6 configuration could deliver, regardless of cost or complexity. This was not a car sold to impress enthusiasts or win magazine comparison tests. It was built almost exclusively for corporate executives, government officials, and imperial household use. Vehicles where the entire engineering brief was reduced to a single obsessive priority: absolute silence and absolute smoothness at any expense. Assembly workers hand-fitted body panels with tolerances so tight that gaps between adjacent panels were individually measured and adjusted on each car, rather than relying purely on mass production jigs. Closer to how a bespoke tailor fits a suit than how a normal automobile rolls off a line. The interior fabric was even engineered to be non-reflective under camera flash, because Century owners were frequently photographed by press at official events, and Toyota's engineers did not want glare from the seat fabric distracting from the passenger's face in published photographs. That is not a specification any normal car company writes down. The V12 engine itself was tuned not for outright horsepower figures, which were never particularly emphasized in Century marketing at all, but purely for silky, imperceptible power delivery. An engineering goal so specific and so far removed from how every other performance-minded manufacturer on this list approached their engines, that it almost belongs to a different category of car entirely. Toyota's own engineers reportedly spent enormous development time simply chasing vibration reduction, isolating the cabin from mechanical noise to a degree that rivaled or beat dedicated luxury manufacturers charging multiples of the Century's price. And despite all of that extraordinary engineering effort, the Century was barely sold outside Japan, remaining almost completely unknown to Western audiences for decades, a genuinely world-class piece of automotive engineering hiding in plain sight, because Toyota built it for one specific cultural purpose and never particularly cared whether the rest of the world noticed. So here's what actually connects all 8 cars, and it is not horsepower, and it is not top speed. Every one of them was built by engineers who were handed a brief that prioritized a specific, uncompromising idea over commercial safety, over conventional expectations, sometimes even over profitability itself. Honda's engineers decided a supercar did not have to be difficult. Nissan's engineers decided a mainstream performance car could beat purpose-built race machines using technology nobody else had deployed at that price point. Mazda's engineers refused to abandon an engine concept the rest of the industry had already declared commercially dead. Toyota's engineers on the Supra built an engine so over-engineered that its true potential would not be discovered for 20 years, while Toyota's completely different team on the Century obsessed over fabric glare in press photographs. Mitsubishi's engineers built a road car almost by legal accident because rally regulations demanded it. Subaru's engineers built genuinely aerospace-inspired aerodynamics and then buried the achievement under a single stubborn transmission decision. And Lexus's engineers, decades later, built an entirely new manufacturing machine from scratch, because no existing equipment on the planet could produce the car they had already decided they were going to build, regardless of the cost. Several of these cars failed commercially. The SVX was undermined by its gearbox. The RX-7 was too demanding for buyers unfamiliar with rotary maintenance. The LFA lost money on every single unit. None of that changes what these cars actually represented, or what they quietly forced the rest of the global automotive industry to eventually catch up to, sometimes taking 20 years to get there. Japan, during this stretch of automotive history, did not simply build advanced cars. It built machines that showed the rest of the world exactly where the industry was eventually going to end up, and then it simply waited for everyone else to arrive. If this kind of engineering history is exactly what keeps you watching until the very last second, you already know what to do next. Because there are far more stories like this one still buried in showrooms, nobody remembers to talk about anymore.